All right, in this one, it tells us that we're trying to determine if having aphids is independent from being sprayed with insecticide. So I'm going to let event A be having aphids, and I'm going to let event B, that's not a B, there we go, B be being sprayed with insecticide. All right. So, for this first problem, I'm going to choose to do the probability of A and B. A intersect B, very good, is equal to the probability of A times the probability of B. Okay, so I certainly could have used the intersection symbol instead of the word and. Make sense? Okay. So in this case, the probability of A and B, that is the intersection. And in terms of what you guys were talking about, the joint and marginal frequencies, if this was a relative frequency table, that would be the joint one in here. But it's not a relative frequency table, it's just a two-way table. So what we have to do to find this probability is to take the 12 and divide it by the total, which is 8. Okay, if we had converted this to a relative frequency table, that's what we would have done, right? All right. Now, how does that compare to the product of the individual probabilities? So the probability of A is the probability of having aphids. That would be 26 out of 80. And B is being sprayed with insecticide, which is 52 out of 80. So at this point, I would probably grab a calculator and convert these to decimals. This is 0.15, and I put it equals there, but we're actually trying to see if they're equal. We're trying to compare this relationship. And when we convert this, we get 0.211. So they actually are not equal. So we cannot statistically prove that these two events are independent. We cannot prove independence statistically. Okay? Does that make sense? All right. Problem number 2 here, I'm going to choose the other method, which is that the probability of A is equal to the probability of A given B occurred. All right, so in this one, I'm going to let A be right-handed, because that's what came first in the wording here. And B be the instrument, playing an instrument. Okay, so the probability of being right-handed would be 220 out of 250. Does that make sense?
Yes.
Okay, how does this compare? How does it compare to the probability of A given B, which in this case is right-handed, given that we play an instrument? So I am only looking at this row. Right-handed. Okay, remember that formula, A given B, is the intersection of A and B over the condition.
That's the second one.
Okay, so the intersection, these are not written as probabilities, but we can do 44 out of 50. Intersection over condition. All right, so what do we get? We get 0.88 is equal to 0.88. They are independent. We have proven them to be independent. Okay. So, does this help those tests make sense?
Yes.
All right. I will ask you on the test to prove independence. So you're going to have to know how to do it, prove it mathematically. Okay, and both these tests are on that summary sheet I gave you. Down at the bottom, number 2 says, how do you prove independence? And then it says this way or this way. All right. So here's number 9, completely worked out.
That's number 9.
Uh-huh.
Let's see what your boy got.
Yeah, they're like slightly different.
Did you round to the nearest hundred? You round to 2 decimal places and got something different?
I must have rounded it wrong, cause
Okay.
like I got 74 point something.
So it would have rounded to 75. Okay.
That makes sense.
Okay, any questions about number 9?
So I did do that. They each one did it. Each do their condition for each one.
Okay, so when we look at this has the highest rating, so therefore group 3. Group 3, which team had the highest rate of customer satisfaction? Group 3.
Oh, I got that right.
I got it right.
I got it right.
I figured that out because I didn't like
Even though your stats were off.
I got that one right. I said it was a bad positive.
and then I found that we have a
I actually said team 2 and. So I got
it
All
worked.
right.
I thought it was gonna be team 1.
All right, that. Okay, so here's 11 and 13 and 14 and 15. Okay. Mine don't add up to 1. They add up to 100.01. Why? Rounding.
I got 0.5.
Miss Bilby, somehow I think I did the wrong number line.
Well, I like
Could have happened.
you know, like
I have a problem about Becky and Ronald and
England I had 0.57, but I didn't like that. So I changed to 0.56.
I didn't know I changed.
Just don't like that number.
I didn't like how it didn't add up to 1, and I also didn't like how it didn't add up to 1 over here, so I changed it. Changed it. I changed it.
Change this one.
Yeah, because it didn't add
Oh,
up.
accidentally got
It didn't add up to, it did not add up to 1. It had to change it. So I just dropped it. I got the interest on your bad.
Okay. I'm going to go to the end of the slide real quick. Tonight's homework is going to be practicing our new topic today, which is compound events. So it's this textbook work. If you look at your printed calendar, it's Thursday's homework. If you look at the online calendar, it's Friday's homework. Okay? So if you want to take a quick pic of what the homework is, you're welcome to. But hopefully, you can also continue working on your review. Remember, Monday is your question day. All of class on Monday is devoted to question time. That's what Monday is. Ask your question.
Is that like every day before test?
Isn't the test Wednesday?
A lot of times. Yeah. Yeah. The test is Tuesday. Tuesday is your test. Yes,
Friday.
Matthew.
Are you online? If not, when will it post?
The review?
Yes.
I think
you're already on there.
I think it's already there. Let's go check. Oh, here it is. Key to review. Key to review. Key to review. It's everywhere. Yeah. All right. So I just want to make sure everybody knew. Please do not save the review, all of it, till Monday night. It's long, and it would do you no good because you do a sorry job. You'd be like, this is way too much for one night. I can't believe she did that. That's what you tell your parents. I know you. But, okay, so do it this weekend, little bits of a time. Don't work more than 30 minutes. All right. Alright, so today, our last topic. This is our last new topic. And you're about to discover it is not new at all. We did it the first day because compound events is something that just makes sense to us. Okay?
Just wait.
No, it really does. You'll go, oh, we've already done problems like this. Yes, we have. You don't need the formula. Your brain just understands it.
So it's compound events. Wait, highlighter, don't I? So, oh my
one thing about when you click next, it didn't go to the next page.
Yes.
Sometimes that happens, especially if you use your phones. It must be a glitch. And did you use a computer and it still wouldn't? I've never had that happen on a
I just
computer.
went to
Okay, but if you go into the where you can type in the page number, if you type in the page number and hit go, I've never had it not work. Yes, ma'am.
I think that might be because like the page doesn't know that you're still logged in.
Oh,
So it's like, oh no, you can't go to the next page.
gotcha. So maybe if you hit refresh first and then,
Sometimes.
okay. Is that what you were gonna say too?
Oh, well, no, I just had trouble logging in, and it was on the computer too. After like putting my username and password in, I used up all 3 of my tries and it kicked me out. So I used the phone. But it let me in.
It let you in on the phone?
Or no, it kicked me out on the phone and let me in on the computer.
Weird. But you got in. Huh, okay. Well, I'll see if I can investigate what's going on there. Okay, so we have a little bit of new terminology today, and this is terminology that just makes sense. 2 events are considered mutually exclusive events if the events cannot occur at the same trial. If they cannot occur during the same trial of an experiment. Okay? So that makes them mutually exclusive if they cannot occur during the same one trial. For example, when you toss a coin, the coin landing heads up and the coin landing tails up are mutually exclusive events because on one trial, one flip of a coin, is it possible for that coin to land heads up and tails up? No, it's not possible for that to happen at the same time. So this would be considered a mutually exclusive event. Yes, ma'am.
Is time a mutually exclusive event?
Is time?
It's like it can't be 2 times at the same time.
It's 3:10 in the morning.
Ooh, that's interesting.
Well, what about if
But, like,
it's 2 different
different
times?
We'll have to put that in context of a problem, and then we could debate that.
Okay.
Okay. So when events are mutually exclusive, to find the probability of event A or event B happening, well, yay, we're finally doing the or. We're finally doing the union. What do you do with those probabilities? You just add them. Now, I gave you questions like this on the very first day of probability and didn't teach you anything, and you got them right. Because this just makes sense. Okay? Here, I think this is on maybe the previous page. Is it on the previous page, this example?
Yes.
A dodecahedral number cube. Okay, so dodecahedral means it's a number cube that has 12 sides. Alright? And those sides are numbered 1 to 12. What is the probability that you will roll the cube and the result will be an even number or 7? Well, if we do a Venn diagram, if they are mutually exclusive, meaning in a single trial it cannot happen at the same time, is there an overlap? No. So here we have even. Okay, my baby's misbehaving. Alright, even. The even numbers are 2, 4, 6, 8, 10, and 12. And here we have the number 7. So there is no overlap. And you would have done this so simply. But this is what it looks like in terms of a probability statement. The probability that it is even or a 7. It's just the probability that it's even plus the probability that it's 7.
Could you write the little U instead of
Could you write the U thing instead of the or? That would make your math teacher very happy.
Oh, the union, yeah. I did.
Yeah. Okay. So this would be 6 out of 12 plus 1 out of 12 would be 7 twelfths.
Oh, you did that.
Okay, and that's it. I did not need to give you a formula for you to know to do that, did I?
Well, it did help.
Okay, I'll take it. All right. But not all events are mutually exclusive. Sometimes things can happen at the same time. Okay? So when they can happen at the same time, on a then, we would have overlap. So let me give you a different scenario. Let's let event A still be an even number on this dodecahedral cube. Okay, but this time event B is going to be a number less than 5. So on a single trial, is it possible to have an even number and a number less than 5? Yes, there's overlap. 2 and 4. So over here, just event A would be 6, 8, 10, and 12. And over here in just B would also be 1 and 3. So what do we do when there's overlap? When there is overlap, when the events are not mutually exclusive, we have overlapping events. These can be called inclusive. If it's not mutually exclusive, it can be called inclusive, meaning it can happen at the same time. Okay, so in our case, the probability of A or B would be the probability of A plus the probability of B, subtracting out the overlap. And we'll talk about why in just a second. So the probability of A or B is the probability of A, 6 out of 12, plus the probability of B, how many numbers are less than 5? 4 out of 12. Minus the probability of A and B. Which is 2 out of 12. So why do we subtract the overlap? Why do we do it? Because 2 and 4 were counted in the probability of A, weren't they? And 2 and 4 were also counted in the probability of B. We counted them twice. We can't count them twice. That's why we have to take them back out. Does that make sense? Okay. So, this is 10 minus 2, 8 out of 12. Now, if I had gone straight to the bin and just counted 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 12. So I could just use the bin, or I could use the formula. The formula is really nice sometimes. It's a lot quicker. Okay, so this would reduce to 2/3, and that's what I would write out as my answer. All right, let's flip over to page 458, and what we're going to do now is read number 1 and decide, is this representing mutually exclusive events, or are they not mutually exclusive, which we could call overlapping or inclusive. Okay, read number 1. Alright, is it possible to draw a marble that is green and red? No. So these are mutually exclusive, right? In one trial, is it possible to draw a marble that is both green and red? No. So, it cannot happen at the same time, right? And when it cannot happen at the same time, they are mutually exclusive. So this would be 5/12 for the red, plus the green is 4/12. So that probability would be 9/12 or 3/4. Okay, so in one trial, is it possible that both happen at the same time? No. Okay, number 2. So now this time we have a 20-sided cube.
How do you say that word?
Icosahedral.
Icosahedral.
sounded better than yours. So,
Ah.
okay, oh, never mind. That was, come on, mature, mature, mature. All right. Is it possible to have a number that is less than 4 or greater than 11 at the same time?
Yes.
No.
Greater than 4,
Less than 4, greater than 11.
Definitely.
So, mutually exclusive.
Yeah, I read it.
All right, so this would be 3/20ths plus, how many are greater than 11? 9 20ths, which is 12/20ths, and 12/20ths reduces to 3/5. Okay, so number 1 and number 2, I could have given you a week ago, and you could have answered these without my help.
No.
I really think you can. All right, number 3, I want you to read it, and first we're just deciding mutually exclusive or not mutually exclusive. All right, ME or not ME? They are not mutually exclusive.
Told you.
Okay, so let's talk about why. Geometry has some vowels in it. It has E
Oh,
and O. So A, E, I, O, U. There's all my vowels. Okay? And then I have letters in geometry. So geometry is G, E, O, M, E, T, R, Y. It's not considered a vowel in terms of probabilities. Okay? So, there are 5 vowels. So I'd have to do 5 out of 26 because there's 26 letters, right? Plus, geometry has 1, 2, 3, 4, 5, 6, 7 letters. And then I have to subtract out the overlap because I counted these twice.
So 2 out of 26.
Very good. So that's 10 out of 26. Now if I just came right here and counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I get the same thing? Yes, I did. And 10 out of 26 reduces to 5/13. Okay, read number 4. Decide if it's mutually exclusive or not mutually exclusive. Okay, what do you think? ME or not ME? Not mutually exclusive. Because there are sums greater than 9 that are even. Like 5 and 5 is 10. 10 is greater than 9 and it's even. Now, it is really easy for me to visualize the sample space in my head when I have two die. But not for everyone, so let's take a look at it. Alright, this is talking about the sum. And it says even. So here's an even sum. These are even. These are even. These are even. These are even. And that one's even. How many of you knew that half of them would be even? Yeah, it makes sense. Half of them would be even. So, the probability that it's even or greater than 9 is the probability that it's even, which we just discovered was 18 out of the 36 possibilities, plus the probability that the sum is greater than 9, and that would be greater than 9. All right, let's change colors. Let's go orange. Greater than 9 would be these. right? Because 10, 11, and 12 are greater than 9. How many are there? 1, 2, 3, 4, 5, 6. 6 minus the probability that it's even and greater than 9. How many are even and greater than 9? Oh, that's the one that are doubled up right now. So this one, this one, this one, and this one. Minus 4 out of 36. Okay, so that's 24 minus 4, which is 20 out of 36, or 5 ninths. It says, what is the probability that the sum of the numbers rolled is even or greater than 9?
Let's just run over it quickly. Sum is even with 9 earlier.
Okay. Hold on. I didn't want you to see that just yet. Okay, so I have 2 things. We're going to do number 8, and then I have one more little concept I'm going to go over at the end. Okay, number 8. I love VINs. VINs are a really good visual way to see what's going on. And so I like to take word problem scenarios, and if there's overlap, I always make a VIN. Especially if I'm doing standardized testing. I use VINs all the time. Anyway, here we have a survey of 1,108 employees, and we find that 621 employees take a bus to work, and 445 employees take a train to work. So we have 2 things going on here. We have the bus, and we have the train. Okay, some employees take both. Are they mutually exclusive? No. If some of them do both to get to work, then no. Alright, 312 only take the train. Find the probability that a randomly chosen person takes the bus or a train. So, since it's not mutually exclusive, the probability of bus or train has to be the probability of the bus plus the probability of the train minus both. P and T. Intersection. Yes. Okay. So, my favorite place to start is in the overlap, but they didn't give it to us. They did give us that 312 employees only take the train. So I can start there. Only in the train part, 312. But 445 take the train to work. So does that help me figure out what goes in here? Yeah. So to find the both, I would do the 445 minus the 312. Alright, and that leaves me 133. Because I add back up real quick. I don't subtract, I always add backwards. Do you guys do that too? I always look at the smaller number and go, what would I have to add to the smaller number to get this?
Nope.
You don't do that?
If I have to do that, I have to do it.
Yeah.
I have to do it both ways.
Oh no. Okay, this is faster, guys. What do you add to 2 to get 5? 3. What do I add to 1 to get 4? 3. What do I add to 3 to get 4? 1. 133. Boom.
Oh, that is
Alright. Okay. I'm not as fast subtracting. I don't know why. That's why I do the other way. Alright, and we have 621 employees that just take the bus. So, if I can do the 621 minus the 133, that would leave me just the bus.
Oh, right.
Because in total, 621 take the bus.
Okay.
So that is 488. Now, you will notice, if you add up these 3 numbers, it does not equal the total number of employees. The total number of employees is 1,108. Why? There's walking, there's cars, there's biking, there's lots of other modes of transportation. We're just investigating the bus and train. So there are lots of other things in this universal space that this problem doesn't address. Alright. But now we have everything we need, don't we? The bus was 612 out of 1108. The train was 445 out of 1108. And the bus and the train was 133 out of 1108. And when we do the math, we get 933 out of 1108. Okay, what do you think I would get if I added up those three numbers?
1,066.
I would get that.
You lied to me.
No,
Okay? So I can either add them up and subtract the overlap, or I can complete the bin and add up what's in the bin. Does that make sense?
See.
Okay. Now, the last thing I want to talk about is the probability of an event or its complement. Think about an event and the complement. Think about what that means. When I say the word or, what is this going to add up to? 1. Very good.
Who said 1?
All the right people. 1. Okay, what about the probability of an event and its complement?
Wait, give me a second. What? Oh, because there's no center point.
Right.
None of them equal. 'Cause-
What is the probability that it's going to rain and not rain?
Yeah.
Well, it can't rain and not rain. 0. What is the probability that it's going to rain or not rain? 1.
100%.
Okay? Does that make sense?
Yeah.
Cool. Alright, so let's revisit homework tonight. Must do. Better do. Or you'll be in a world of hurt Monday
That
night.
is a lot though.
Okay? So, it is a lot. That's why I gave you the review. When?
Thursday,
Wednesday I gave you the review.
I thought it was Monday, honestly.
Okay. Alright, now,